Welcome to Get Your FRQ On. This question is from 2013. It's question 6, and it is not calculator active. In the question stem, we are given a differential equation, dy dx. You can check that out yourself. The link to the actual questions is in the description. And in part A, we are asked to find the tangent line to the function f at the point 1, 0, and then also to approximate the value of f of 1.2 using that tangent line. All right, so we're given that dy dx is equal to e to the y times 3x squared minus 6x. All right, we need to know the slope of the tangent line at 1, 0. So to do that, we're going to evaluate dy dx at 1, 0. And when we substitute in those values for x and y, we get dy dx to equal -3. So dy dx at 1, 0 is -3, so that would be the slope of our tangent line. We also know the x and the y coordinates that this tangent line must go through. It's 1, 0, so the tangent line at 1, 0 will be y minus 0 equals -3 times x minus 1. I typically will write these equations in point-slope form because it's the easiest to get giving the information that you have. And once you have an equation for the tangent line that's correct, there's really not much point in working with it any further. Make sure you lock that point up. And then to use this equation to approximate f of 1.2, f of 1.2 would be -3 times 1.2 minus 1, which is -3 times 0.2, which is -0.6. In part B, we are asked to use the initial condition 1, 0 to find an actual function y equals f of x. To do this, we're going to have to use separation of variables. In fact, usually when you have to solve a differential equation on the AB exam, the expectation is you will use separation of variables because it's typically the only method that is expected to be taught in the AB part of the course. And if you don't use separation of variables, you put a lot of points at risk. So make sure you understand how to do separation of variables. All right, so we're given in the question stem that dy dx is this function e to the y times 3x squared minus 6x. So if we're going to use separation of variables here, dividing both sides by e to the y, we get e to the -y dy equals 3x squared minus 6x dx. So if we add in the integrand on both sides and then integrate, we have the integral of e to the -y dy equals the integral of 3x squared minus 6x dx, which implies that -e to the -y is equal to x cubed minus 3x squared plus some constant c. All right, so that means that e to the -y is -x cubed plus 3x squared plus some constant c. Notice I don't really have to change the sign on the c because I haven't solved for c yet, so c could be positive or negative at this point. There's no point in writing it as subtraction. And then if I take the natural log of both sides and then get rid of the negative sign, we have y equals negative natural log the absolute value of -x cubed plus 3x squared plus c. All right, so if we use our initial condition here, we know that y is supposed to be 0 and x is supposed to be 1. So 0 is the negative natural log of the absolute value of the opposite of 1 cubed plus 3 times 1 squared plus c. And this would allow us to conclude that c is -1. Now, because our x value is 1, when we plug that in, the expression -x cubed plus 3x squared minus 1 is still positive. So as far as our solution is concerned, because it has to go through the point 1, 0, and at 1, the expression inside the logarithm is already positive, we may omit the absolute value. All right, so our actual function y would be y equals the negative natural log of -x cubed plus 3x squared minus 1.